In chemistry lab, Jason has to make 37 milliliters of a solution that is 12% hydrochloric acid. All that's in the lab is an 8% hydrochloric acid solution and a 15% hydrochloric acid solution. How many milliliters of each solution should he use to obtain the desired mix? So this is kind of what we call a standard mixture problem. And we want to start with the variable key. So we need to ask ourselves, what are the unknowns? What do we not know? And that is usually given to us in the actual question. How many milliliters of each solution? So he has these two solutions, an 8% hydrochloric acid solution and a 15% solution that he wants to mix together, and we don't know how much of each he should mix. So I'm going to let X be the number of milliliters of the 8% solution, and I'll let Y be the number of milliliters of the 15% solution. And remember, the letters that you choose here are not important. I chose X and Y, you could choose A and B, it doesn't make a bit of difference. So there's our variable key. And for mixture problems, I kind of like to set up something visual for myself. So I use canisters to represent my first solution, and then I'm going to add some of the second solution together to the first, and that'll give me a final solution. This often will help students set up their equations. So I'll label my first solution that I have an 8% solution, 8% hydrochloric acid, and then I have a 15% hydrochloric acid solution. And our goal in the end is to make a solution that is 12% hydrochloric acid. So up top in the cylinder, then I write how much I have. So how much do I have of this 8% solution? Well, that's my first unknown right there. That's X. I don't know how much I have of the 8% solution. I have X milliliters. And then I have Y milliliters here of my 15% solution. But in the end, if you reread the problem, it tells us that we want to have 37 milliliters of a 12% solution. So up here I'll write 37. That's how many milliliters I want to have total in the end. So now we're ready to set up our system of equations. And remember, when you count your unknowns, that's how many equations you need. So 2 unknowns means I need 2 equations. So my first equation is just going to be what I call a milliliter equation. The very tops here of the canisters. I'm going to add X milliliters to Y milliliters and get 37 milliliters in the end. So that would be just X plus Y is equal to 37. So you could put a label on this equation if you want. You could say this is a milliliter equation. It's how much I have total in each of my canisters. But then my next equation is going to deal with how much acid I have. So looking at the end result, I want to have 37 milliliters, but I want it to be 12% hydrochloric acid. So to actually figure out how much acid I have, 12% of 37 milliliters, that would be 0.12 times 37. And if you multiply, 12% of 37 is going to be 4.44. So this is actually how much hydrochloric acid we have, or we want, I should say, in the end. And notice I got that value by multiplying the number of milliliters by the percentage. So I need to do the same thing for each of my canisters. This first canister, I want it to be 8% hydrochloric acid. So 8% of X would be written 0.08 times X. Plus, my second canister, I want to have 15% hydrochloric acid. Or I should say, I have 15% hydrochloric acid. How much I have in the canister, I have Y milliliters, so 15% of Y is 0.15 times Y. And in the end, I want a solution that's 12%, and 12% of 37, over here I've already done that multiplication, 12% of 37 is 4.44. So this equation that I have in blue, this resulted from me multiplying how much I had in each cylinder times the percentage of hydrochloric acid. And so now we have our system of equations, and we want to move forward and solve. Now the methods for solving a system of equations algebraically, there's 2 methods. The methods are either substitution or elimination. And for this particular problem, see how the variables, the x variables here are stacked on top of one another, and then we have the y variables next that are stacked, and then on the other side of the equal sign, we have the constants. So this is the nice setup for elimination. So I'm going to do elimination. We want to add these two equations together and eliminate a variable. So because of my coefficient here of 0.08, I need to multiply my top equation, and I'm going to have to multiply by negative 0.08. So that means that the left will need to get multiplied by negative 0.08. But of course, what we do to the left side of an equation, we also must do to the right to keep this equation in balance. So I'm going to multiply the right side. Having trouble getting it to right. There we go. Multiply the right side also by negative 0.08. So I'm going to put my result over here to the right. So multiplying my entire equation by negative 0.08 will give us negative 0.08x minus 0.08y is equal to negative 2.96. And then my bottom equation was 0.08x plus 0.15y is equal to 4.44. So now I can go ahead and add the two equations together. And you'll notice when I add the two equations together that I will successfully eliminate the variable x, because negative 0.08x plus 0.08x will just give me 0. So then adding our y's together, we're going to have a positive 0.07y is equal to 1.48, and then dividing by 0.07 will give us that y is approximately, doesn't work out exactly, but approximately 21.14. We'll just round to 2 decimal places. So as always, two things you need to check at the end. Make sure that you reread the problem so that you've actually answered the whole question, and then make sure you have the correct units. So going back to our problem, the question was how many milliliters of each solution? So we need to know the amount for each, and looking at your variable key, you'll notice that x and y were both measured in milliliters. So that tells us that our answer right here is that we have 21.14 milliliters, and that was y, which was my 15% solution. So we want 21.14 milliliters of the 15% solution. And now we need to find x. But if you go back to your very first equation, before we did any of this multiplication here, we had an equation of x plus y is equal to 37. So therefore, I can just take 37 minus 21.14 to get the other amount, the amount that I should have for x, which gives 15.86. So then I need 15.86 milliliters of the other solution, which was the 8% solution. And now I've successfully finished the problem.